Hello all, and welcome to Inverse Matrices Part 1. What we're going to be covering in this matrices. What we're going to be covering in this video is how to tell whether two matrices are actually inverses of each other. In the next video, Inverse Matrices Part 2, we'll discuss how to actually find inverse matrices. Now, two matrices, when they're inverses, will multiply together to be what is known as the identity matrix. Okay? The identity matrix is, when we're dealing with 2 by 2 matrices, is 1, 0, 0, 1. Again, two matrices that are inverses will multiply together to be this matrix. Okay? This is the identity matrix, and it's called that because if you recall, identity property is 5 times 1 equals 5. It keeps its identity when it's multiplied by 1. Matrices are a little bit more complicated. We can't just multiply them by 1 for them to stay the same. Okay? What we have to do is they have to multiply together to be this, because if you take a matrix, let's say just A, B, C, and D, and you multiply it by the identity matrix, 1, 0, 0, 1, you get this same matrix again as your answer. So in a sense, it keeps its identity when multiplied by the identity matrix. That's how it gets its name. So, how to tell whether two matrices are actually inverses of each other. All you do is, say we're given a matrix like matrix X, and it is 4, 2, negative 1, and negative 2. And we get another matrix, let's say 1/3, negative 1/6, negative 2/3, and 1/3. Okay? How to tell whether they are in fact matrices is to just multiply them together, and if it comes out to be the identity matrix, then they are in fact inverses. So let's multiply these two matrices together. So xy is, this is a 2 by 2, and this is a 2 by 2. So a little review of multiplying matrices. The inner two numbers need to be the same. Well, they are. So the outer two numbers tell us the dimensions of our answer. So our dimensions of our answer is going to be a 2 by 2 matrix. So we're going to draw a skeleton matrix that is a 2 by 2. Now let's multiply these two together. This is the first row, first column. So we're going to go first row, first column. So 4 times 1/3 gives us 4/3, and then plus negative 1 times 1/3 gives us negative 1/3. Now move on over. We've got first row, second column. So we're going to go again first row, but now we're going to go over here to the second column. So 4 times negative 1/6 gives us negative 4/6, plus negative 1 times negative 2/3 gives us positive 2/3. Let's fix that. There we go. 2/3. So now let's move down here. Now we're in the second row, first column. So now we're going to use the second row in our first column. 2 times 1/3 gives us 2/3, and then negative 2 times 1/3 gives us negative 2/3. Moving over, still second row, but now we're in the second column. So second row, second column. 2 times negative 1/6 gives us negative 2/6, plus negative 2 times negative 2/3 gives us positive 4/3. Now all we need to do is simplify this matrix. 4/3 minus 1/3 gives us 3/3, which is 1. Negative 4/6, that simplifies down to negative 2/3. Well, negative 2/3 plus 2/3 gives us 0. Over here we've got 2/3 minus 2/3, duh. And then negative 2/6, which is negative 1/3, simplified down, plus 4/3 gives us 3 over 3, which is 1. If they multiply together to be the identity matrix, which they do, 1, 0, 0, 1, then they are inverses. So in this case, x and y are inverses of each other.